Hi, it's Organic Friday, and we're here to talk about a class of compounds called alcohols. I wanted to start by introducing the functional group, the structural formula for alcohols, and basically what's going on with an alcohol is that it contains a hydroxyl group, a covalently bonded OH group attached to a carbon chain. So the basic formula that you're going to see with an alcohol is some carbon-containing group, which we'll call R, with an OH group attached. That's what we mean. Now, alcohols do actually come in different classes. We can talk about primary and secondary and tertiary alcohols. To some extent, this goes a little bit beyond what we need for AP chemistry, but it does affect the reactivity of these. So I thought I'd mention it. So for those of you going on in chemistry, you'll have heard of this before when you need it in your organic course. So what I mean by a primary alcohol is that the alcohol group, the OH group, is attached to a carbon that's attached to only one other carbon. All right? And so this would be an example of a primary carbon. All right? You'll see that the carbon holding the OH group is only attached to one other carbon. And we can also talk about secondary alcohols, That might be something like this. Where the carbon to which the OH group is attached to connected to two other carbons. All right, we can also have a tertiary alcohol. All right, where the carbon attached to the hydroxyl group is attached to three other carbons. So I just wanted to mention this so that you've heard of it before when you need it. All right, now our main focus, beyond being able to recognize an alcohol group, is to be able to name alcohols and write formulas from names. So you're really looking at two things. You need to know where the hydroxyl group is attached. You have to give the number of that carbon if there's more than one possibility. And what you do then is you find the longest carbon chain, all right, and find the name of the alkane that would correspond to that longest carbon chain, and then you add OL to the name. You would drop the E. All right, so we'll do some nice simple examples of this. All right, for example, one of the molecules that we drew on a previous page, all right, was this molecule. All right, now this has a hydroxyl group attached to a two-carbon chain, and so we call this ethanol. All right, but you may also see this called ethyl alcohol, which is an alternative name. It's not really the preferred name these days, but it certainly would be recognized. So you'll see this called ethyl alcohol. This is sometimes called grain alcohol, colloquially. All right, and I do want to mention that the alcohols are toxic. They can cause blindness, death. All right, all the alcohols are toxic, so just be careful. All right, let's name some other compounds. Well, we just named this one. We know that this is ethanol. All right, you can look at this molecule right here. There's one carbon in it, so we're going to call this methanol. All right, sometimes you'll see it referred to as methyl alcohol. And this is sometimes referred to as grain alcohol. This is toxic. It will cause blindness. Do not consume it. I wanted to mention another possibility here. We've got 2-propanol. All right. So we have to work backwards for the name. The prop prefix is telling us that there are 3 carbons in the chain. All right. And the number 2 is saying that the hydroxyl group, which is indicated by OL, the second carbon is where the OH group is attached. That's what 2-propanol means. All right? And so then we can fill in the other spaces, the other bonds for carbon with hydrogens. So this would be 2-propanol, all right, as opposed to 1-propanol, which would be also a 3-carbon chain, but the OH group would be attached to the first carbon, or an end carbon. Remember, we're always going so we get the lowest number. I wanted to mention this to you so that you know how to draw these, all right? And alcohols are important because they, under the right circumstances, they can be turned into other classes of organic compounds with the right reactions. And so they're a fundamental thing that you really should know about. We're going to stop here, and we'll talk another time.